Okay, we're going to start our Unit 7 review for logarithms and exponential functions, and we're going to start with converting back and forth between exponential and logarithmic forms. So we're going to start with these exponential form problems for question 1 on the review and convert them into logarithmic form. So in order to do that, we're going to have to begin with question 1a, 3 to the 4th power equals 81. If I want to put this in log form, my log is going to need to have a base, and the base is the same base as my exponential function, 3. And I'm going to have to raise that to the log of 81, so 3 log base 3 of 81, and then it's going to equal 4. So that's that roll back motion. We start with a base, it rolls over to the number 81, and then rolls back to the number 4. So log base 3, 81 equals 4. And that one's all finished. Let's go ahead and try example B. Again, my log is going to have a base. So my base is going to be the base of my exponential function, 1/2. It's going to be of the number on the other side of the equal sign, 1/16, and it's going to equal, again, the number 4. Got one more to convert here. So again, my log is going to need a base. The base is the base of my exponential function, 36. It's going to be log base 36 of 6, and it's going to equal x. And that's it. Question 1 is done. Let's go ahead and take a look at converting from logarithmic to exponential. So now we're going to look at some log rolls. So in question 2, we're starting with logarithms, and we're going to convert them back to exponential form. So in example A, we have log base 2 of 64 equals 6. I'm going to have to put this in exponential form. So I'm going to need a base of my exponential function, and it's going to be the same base of my log, 2. I'm going to raise that 2 to the 6th power, and it's going to equal 64. So we can see that rolling motion there with my numbers. 2 to the 6th equals 64. Let's go ahead and try example B. We're going to need the base of our log, 81. We're going to raise it to the power of the number on the other side of the equal sign, x. That's going to equal the number from inside the log, 3. All right, last one here, log of 1 over 1,000 equals -3. This log has an invisible base. The base is the number 10, so that's the number I'm going to start with. I'm going to take my base and raise it to the -3rd power. If I do that, it will equal the number inside the log, which is 1 over 1,000. Okay. So that's it for converting back and forth between exponential and logarithmic form. Let's go ahead and try question 3, which is evaluating logarithmic expressions. Now, in order to evaluate, I could use the change of base formula. The change of base formula will give me either whole numbers, which are great, or decimals, which are good if that's what we're looking for. But if my answer can be expressed exactly as a fraction, the change of base formula won't give me that fraction. It will only give me the decimal version, which has been rounded. So I would prefer to find my answers with a different method. I would prefer to look at the logarithms for what they mean. So that means I'm going to go ahead and convert them to exponential functions first, because a logarithm is solving for an exponent. So I'm going to go ahead and convert log base 2 of 32 into an exponential function. Now there's no equal sign here, so I can invent my own equals x, so I know that it equals some number on the other side. And I can go ahead and do a log roll, 2 to the x power equals the number 32. Now all I have to do to solve this problem is give both sides equal bases so I can compare their exponents. So that means I'm going to take the number 32 and rewrite it as 2 to a power. I may not know what power, but I can find out by just taking the number 2 and multiplying it by itself until I find the number 32. So 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. And there we found it, and it took me 1, 2, 3, 4, 5 2's. So 2 to the 5th power. And that equals the 2 to the x on the other side. And now that I have like bases, I can go ahead and set my exponents, x and 5, equal to each other. So x must equal the number 5 if both sides of these equations are equal. Let's go ahead and try example B. We're going to start it the same way. I'd like to figure out what this means in exponential form so that I can solve it. So I'm going to insert my own little invisible equals x and do a log roll here. So 27 to the x power equals 3. Now all I have to do is try to rewrite both sides with the same base. This time it might be a little bit more challenging because the base is actually going to change on this side. I might be able to rewrite both sides of this equation as 3 to a power. So I'm going to have to rewrite the number 27 as 3 times itself a certain number of times. 3 times 3 is 9, times another 3 is 27. So I needed 3 times, 3 to the third power. Now that 27 is also being raised to the x power. So we're still going to be raising this to the x power as well, and it's still going to be equal to the number 3. All I have to do now is realize that the 3 on the right-hand side, that 3 by itself, is being raised to the first power, and here I have like bases, 3 to the 3x and 3 to the first. They equal the same exact thing, which means that 3x must equal the number 1, and all I have to do to finish solving for x is divide both sides by 3. So x is 1/3. And that guy's all done. Up last, we're going to solve example C, which is log base 6 of 58. Now this problem works a little bit differently. I can absolutely start it the same way as before. To start this problem, I would have to do a log rule, and I would get that little invisible equals x, 6 to the x power equals 58. But the problem here is that I can't multiply 6 by itself to get the number 58. If I do 6 times 6, I get 36, and I think if I multiply it one more time, I get something like 216, which is way too big, and I never reach the number 58. So I'm not going to be able to give these like bases, which means I can solve this problem another way. Either I can go back to my log and use the change of base formula, or I can keep it in exponential form and I can do a log on both sides. So if I do a log on both sides here, I end up with the log of 6 to the x power equals the log of 58. I can move my exponent x to the front of this log. X times the log of 6 equals the log of 58. And then all I have to do is divide both sides by the log of 6 to get my final answer. Log 6 divided by log 6. My final answer would just be x equals whatever this is in the calculator. And if we type in log 58 divided by log 6 in the calculator, we get 2.266. So there was no nice whole number or fraction solution for this problem. It was this decimal instead. All right, so that's it for converting back and forth and evaluating these logarithms. We're going to pick up with using properties to expand and condense in the next video.